Next topic, type 1, logarithmic decrement problems. So important formulas used in these type 1s are: first one, circular natural frequency omega n. Formula is square root of k pi m, or for circular motion, circular disk, it is square root of kt by I, where k is the stiffness of the spring, or for circular shaft, kt is stiffness of the shaft, m is the mass of the suspended mass of spring, and I is mass moment of inertia of a shaft, rotating shaft. Second one, frequency Fn is 1 by 2 pi omega n, or omega n is 2 pi by Fn in hertz. Third one, damped frequency Fd is 1 by 2 pi omega d, or omega d is 2 pi into Fd. So omega d is also omega n upon 1 minus zeta square. Zeta is the damping ratio or damping factor. So fourth one, damping factor, damping ratio, zeta is C by Cc. C is damping, C is actual damping, Cc is critical damping. So critical damping Cc is also given as 2m into omega n. For circular shaft, it is Ct by Ctc. Cc circular, fifth one, Cc critical damping is 2m omega n, or this can be also written Cc can also written as 2 into root of mk, or Cc can for circular shaft can be written as 2 into root of kt into I, or 2 into I into omega n, where I is mass moment of inertia of shaft. Similarly, sixth one. So now logarithm formula, logarithm decrement delta is ln of x1 by x2, or ln of xn plus 1, or so logarithm decrement delta can be also written as 2 pi zeta upon square root of 1 minus zeta square, or logarithm decrement also for n number of cycles can be also written as delta equals to 1 by n ln of x2 by xn for n number of cycles. So kt is a stiffness of a circular shaft, is gj into L, where g is the modulus of rigidity, j is polar moment of inertia, L is the length of the shaft. Delta for circular amplitudes, logarithm decrement delta can be also written as ninth one, delta equals to ln of theta 1 minus theta 2, where theta 1 theta 2 are the angles turned by circular shaft in a circular frequency. 10th one, ratio of successive amplitudes x1 by x2 is e raised to delta, or e raised to 2 pi zeta upon square root of 1 minus zeta square. Example 1, 3.5. A mass of 10 kg is suspended by a spring of 2 Newton per mm stiffness and has a damping force of 5 Newton at a unit velocity of 0.1 meters per second. Determine the damping factor, logarithm decrement ratio of successive amplitudes, and amplitude of after 10 cycles if initial amplitude is 15 mm. So given m is 10 kg, stiffness of spring k equals to 2 Newton per mm, or 2000 Newton per meter. After converting, damping force F is 5 Newton, damping velocity is x dot is 0.1 meters per second. So therefore, first we should calculate the actual damping C. So actual damping C, the formula is damping force by upon its unit velocity. So damping force C is F upon x dot. F is 5, damping velocity is 0.1 meters per second. Therefore we have F 5 upon 0.1, that is equals to 50 Newton second per meter. This is the actual damping. Now next we have to find the critical damping Cc. Critical damping Cc is 2 m omega n, or 2 into root of mk. Also mk are already given, so 2 into root of 10 into k is 2000. So we have 282.43 newton second per meter. So everything should be in meters and newtons. So damping factor zeta is c by cc. 50 upon 282.843, we have 0.1768. Now damping factor zeta is less than 1 by the value. Since it is less than 1, now the system is under damped system. So noting under damped system. So it's under damped system. So now we can find the logarithmic decrement. So logarithmic decrement delta is formula is 2 pi zeta upon square root of 1 minus zeta square. So substitute the values of zeta, that is 0.1768. 2 pi was into 1.78 square root of 1 minus 0.1768 the whole square. We have 1.1286 is the logarithmic decrement value. So ratio of successive amplitudes. So taking the ratio of any two of the amplitudes, we get the ratio as xn by xn plus 1, that is e raised to delta. So e raised to delta, we have 3.0915 is the ratio of successive amplitudes. So each amplitude reduces by 3 times the initial amplitude. Now to find the amplitude after 10 cycles, if initial amplitude was 15 mm, so the number of cycles are 10, n is 10, and initial amplitude x0 is 15. Therefore the delta formula for n number of cycles is delta equals to 1 by n of x0 by x10. So x10 is delta is we know delta is 1.1286. 1 by 10, ln of x0 is 15, x10 is 1.82 10 raised to minus 4 mm.